Good morning, friends. In this occasion, we are going to discuss a really interesting topic, which is based on our knowledge we gain from our department, which is computer science or informatics. The topic is called machine learning to discover COVID-19 treatments. So before we begin to present this discussion, let us introduce ourselves. My name is Dionysius Tiksa Pratito, and our other members are Kevin Davis Samuel and Rehan Naval Rahman. So this presentation is divided into three major parts. The first one is introduction, the second one is main topic, and the last one is conclusion. So I begin with the introduction. Researchers are using machine learning algorithms capable of generating millions of therapeutic antibodies to quickly find treatments for COVID-19. Before we dig deeper into this case, we must first know what machine learning is and how does it work. According to Wikipedia, machine learning is the scientific study of algorithms and statistical models that computer systems use to perform a specific task without using explicit instructions, relying on patterns and inference instead. In a nutshell, machine learning is the science of getting computers to act without being explicitly programmed. In the past decade, machine learning has given us self-driving cars, effective web search, and a vastly improved understanding of human genome. So how does machine learning exactly work? Machine learning uses two types of techniques. The first one is supervised learning, which trains a model on known input data and output data so that it can predict future outputs, and unsupervised learning, which finds hidden patterns or intrinsic structures in input data. So unsupervised learning group and interpret data based only on input data. Supervised learning develop predictive model based on both input and output data. What techniques we use when we working with machine learning really depends on our needs. We choose supervised learning if we need to train a model to make a prediction. For example, the future value of a continuous variable, such as temperature or a stock price, or a classification. For example, identify cars or people from a video footage. We choose unsupervised learning if we need to explore our data and want to train a model to find a good internal representation, such as splitting data up into clusters.
Let's move on. Main topic. Okay, how do researchers use machine learning to discover treatment for this novel disease? And with coronavirus on everyone's mind and forcing almost all of us to indoors, many in the machine learning community are wondering how they might help. As we will see in the next slide below, machine learning can help expedite the drug development process and provide insight into which current antiviral might provide benefits and forecast infection rates, and finally help screen patient faster. Caution: almost all of the paper and data mentioned here are very recent and thus have not been peer reviewed or verified. Treat claims with skepticism. And in addition, the normal best practices with machine learning, I recommend consulting with at least one specialist in the relevant field. For example, epidemiologist, chemistry, biologist, etc. This provides a sanity check, as sometimes machine learning researcher can misinterpret the problem that needs to be solved. Also, it's important not to contribute to the already significant amount of misinformation going around. Okay, application of machine learning. First, predict the structure of protein and their interaction with chemical compound to facilitate new antiviral drug. Our vaccine recommended current drug method here are really on applying deep learning to molecules such as protein. And second, forecast infection rate and spread prognosis to enable hospital officers to better plan researching and response. There actually have not been too any model at least publicly documented one, that have explicitly attempted to model the coronavirus spread. However, significant amount of prior research has studied forecasting the seasonal flu and other outbreak. Interestingly, large number of the methods currently being used to forecast disease spread and patient mortality are based on a shallow model. Okay, that's it for me.
So, we getting into the last part of this topic, conclusion. In summary, there are many potentially impactful applications of machine learning to fight the COVID-19. However, more are still in their early stages. Moreover, a lack of data sharing continues to inhibit overall progress in a variety of medical research problems. However, I believe that utilizing things like meta learning, domain adaptation, and reinforcement learning while loosening restriction to healthcare data can allow machine learning to play an important role of containing or responding to both coronavirus and future pandemics. And last but not least, stay safe everyone. So this is the presentation of our group. Thank you for your attention. See you